Kia ora Year 11 and 12. Here's part 2 of the Summer 2019 Vectors questions. So I've put the questions on here so that you can have a look at them. So pause the video and have a go at them. Now I'm going to give you a few hints. So the first question is one where we've given 2 points with position vectors, right? And we're given a line L, and it's got this vector equation of the line, and we have to show that L doesn't intersect the line going through A and B. So the first thing we're going to do here is get a vector A from A to B, and then we're going to do another line which we'll call R2, and that's going to have the equation of a line with a parameter of lambda. Then we're going to try and show that there's no such values of lambda and mu that are going to satisfy the 3 different equations for the x, y, and z coordinate. Right, so that's a pretty straightforward question. You just have to be really careful with your communication in that one. Now the next one looks hard, but it's actually not. And it's about a plane. We're given a plane M, and the plane M is perpendicular to AB. Right, so that's the AB from back up here. And it goes through the midpoint of AB, so that's going to be easy to find. Now, if you think about what we need for a plane, we have to have a normal vector. And the normal vector we will often find by knowing that we've got 2 different lines that are in a plane, and knowing that the plane will be perpendicular to both of those lines. And then we use the vector product or the cross product to find that normal vector. If you start thinking like that for this question, you're going to miss something really, really massively obvious, which is that we're told that the plane is perpendicular to AB. And that means that that will be our normal vector. And I think it's pretty easy, if you don't spot that, to waste a whole lot of time on this question, making it harder than it really is. Then we have to find the equation of the plane, and then we've got a classic question where the plane intersects the line L at point P, and we just have to find the equation and the position vector. I've taken some time to go through both of those because I think for some of you, as we get really close to exams, it's something that you're still not doing enough. So always make sure that you skim read the whole question before you get going, because there will often be clues for the second part coming from that first part. Right, so let's get into it now. Right, I'm going to start off by writing out the line L like this. So R is equal to 2, 1, 1 plus mu times this column vector 1, 1, 2. And we could write that straight away as 2 plus mu, 1 plus mu, and 1 plus 2 mu. Now I'm writing it like that straight away because I'm going to be working with showing that it doesn't intersect. So you know that we're going to need it in that format. The line through AB can be written in several ways, but we're going to need a direction vector. So we can take that to be 3, 1, 1, the position vector OB, minus 1, 2, negative 1. So that gives us a direction vector here of 2, negative 1, and 2. Of course it will work the other way around. And so the line, we'll call it R2, is going to have a point on it, or a position vector on it. So I'll take that as A, 1, 2, negative 1, plus lambda times that direction vector. So now we've set up our 3 equations. We've got these, and we're going to try and solve them simultaneously. Now you can pick any combo for what you're going to do, but I'm just going to pick the first 2 equations. So we want to say something like this. We want to find lambda and mu such that R1 is equal to R2. So we have 2 plus mu is equal to 1 plus 2 lambda, and 1 plus lambda is equal to 2 minus lambda, and it's worth labelling those equations 1 and 2. So let's clean those up first. We've got mu is equal to negative 1 plus 2 lambda, and then we've got mu is equal to 1 minus lambda. So we might as well use substitution here. So we've got negative 1 plus 2 lambda is equal to 1 minus lambda. That gives me 3 lambda is equal to 2. So lambda is equal to 2/3. We're going to take that, and now we're going to find a value of mu, which is 1 minus 2/3, or 1/3. Right, so our next task is to take those values for mu and lambda and substitute them into our third equation, which is that this needs to equal this. So let's work with the left-hand side first. The left-hand side of the equation is 1 plus 2 mu, so that equals 5/3. The right-hand side, however, should be -1 plus 2 lambda. So substituting in here, we get -1 plus, what was our lambda, 2/3 up here, right? So plus 4/3, which gives us 1/3. So we need to clearly explain that that is not equal to 5/3. Therefore, lambda mu equals 2/3, 1/3 doesn't solve equation 3. Therefore, no solution to R1 equals R2. Therefore, lines don't intersect. Okay, so that's the first part of that problem solved. Let's see what we have to do next. Okay, so now we're into the bit with the plane. And we have to show, so we've got the plane perpendicular to AB and going through the midpoint of AB. So here's my vector AB again. So we're going to take that to be the normal vector. Right, so the equation of the plane is going to be 2x minus y plus 2z is equal to c. But we know that the midpoint of AB is as follows. So if we go back to what A and B were, it's going to be this: 1 plus 3 over 2, 2 plus 1 over 2, and -1 plus 1 over 2, which gives us 2, 3 over 2, and 0. So where did that come from? Well, back up in here, we had a position vector for A and a position vector for B. Right, so I've taken those and chucked them in here to get the midpoint. Right, so what can I do now? Well, I need to substitute that midpoint point in to get my constant in the plane. Right, so 2 times 2 minus 3 over 2 plus 0 equals c. So c is equal to 4, so 8 over 2, so c is equal to 5 over 2. Right, so let's clean up. I'm just erasing as I go, which is kind of messy, sorry. Let's get rid of that. So my plane equation, we've got most of it already. The plane equation is 2x minus y plus 2z is equal to 5 over 2. Now that's horrible having a fraction in there, so let's make it 4x minus 2y plus 4z is equal to 5. Right, so that's the equation of the plane. Now what do we have to do with it? Right, well the plane intersects the line L, which is coming from up here, at point P. Find the equation of the plane. Yep, we've done that, and now we have to find the position vector of P. Right, so we've got 4x minus 2y plus 4z is equal to 5. And we've got a line L has got the following position vector for any point on line L. It's this. Okay, so we want to find where the plane intersects the line. Well, it's pretty simple. We take each of these and we substitute them into the x, y, and z. So we're looking for the value of mu where the line and the plane will meet. And we get 8 plus 4 mu Right, let's do the constants carefully first. It's very easy to muck these bits up. So we'll do the mu's first. So we've got 4, take away 2 is 2, plus 8 is 10 mu. And I've got 8 minus 2 is 6. 6 plus 4 is 10. What does this give me? Well, it gives me 10 mu is equal to -5. Mu is equal to -1/2. So now we can find the point on the line where the plane and the line meet. So 2 plus mu, 1 plus mu, 1 plus 2 mu. So the vector that gets us to point P is 2 plus mu, 2 minus 1/2, 1 plus mu, 1 minus 1/2, and 1 minus 2 mu, 1 plus 2 mu is 1 minus 1, which is 3/2, 1/2, or 0. Now, I think we were asked for it as a point. Let's go back to the question. Where's it gone? Right, we've got to find the position vector of P. So no, we do want it in position vector form. I think they'd probably accept it with coordinates, but now we've lost it completely. Right, so, yep, the position vector is that. So that's that question done. So the first part, very, very common and a really useful skill to look at whether a line intersects another line. So that's a simultaneous equations question. And the next one was easier than usual because we were given the normal vector directly in the question, right? So if you missed that fact, you probably would have gone off on a wild goose chase for a while. Thanks for watching. I'm going to finish off with paper 33 in a few minutes.